Unit 11. Electricity. Lesson 11. Electricity. Introduction. Electricity is a general term of a variety of phenomenon resulting from the presence and flow of electric charge. Some common phenomena related to electricity are lightning, static electricity, and the flow of electrical current in an electrical wire, whereas electromagnetic field and electromagnetic induction are less familiar concepts. Electrical effects were produced classically by rubbing amber. Current electricity. The present age is called the age of electricity because at every step of our life we take the help of electricity. Electric energy can be easily converted into other forms of energy. Since electricity can be generated by using chemical, heat and magnetic energy, the use of electricity is widespread in the world. The electricity produced by continuous flow of electron through circuit is called current electricity. Current and its measurements. We have known that a body can be charged by friction. When these charges are made to flow in a circuit, the motion of them becomes an electric current. The flow of charge per second is called electric current. The SI unit of current is ampere. The small amount of currents are measured in milliampere and microampere. Charge of 1 electron equals 1.6 times 10 to 19 C. Thus, when 1 ampere of current flows in a circuit, 6.25 times 1018 number of electrons flow in 1 second across the wire. Electric circuit. The source provides the current. Electric loads are connected with the source by the conducting wire. The current from the electric source passes through the load and the load works. If the switch is used in the circuit can be of two types, I. Closed circuit, I. Open circuit. I. Open circuit. The circuit in which there is a break or disconnection is called open circuit. Current cannot flow through the such circuit. I. Closed circuit. The circuit in which there is no gap or discontinuity is called a closed circuit. Current can easily flow through such circuit and bulb can blow. Ammeter. The instrument which is used to measure the magnitude of current flowing in a circuit is called an ammeter. The ammeter has a red-colored terminal which is positive and a black-colored terminal which is negative. To connect an ammeter in the circuit, the red terminal is connected to the positive side of the circuit and the black to the negative side. Potential difference. The term potential is very important in electricity. When a body is charged, it acquires a potential. The body having an excess of electrons is said to be at a negative or lower potential, while the body having an excess of positive charges is said to be at a positive or higher potential. Analogous to the water level which determines the condition for the flow of water, the flow of charge from one point to another depends upon a property which is called electric potential. The amount of work done in moving a unit positive charge from one point to another in an electrical circuit is called potential difference, PD. Work, W equals charge, Q times potential difference, V. Voltmeter. The instrument which measures the potential difference across any 2 points in a circuit is called a voltmeter. Ammeters are connected in series, but voltmeters are connected in parallel. Ammeters are the devices which are used to measure the current and are necessary to make the flow of current through them. Voltmeters are the devices used to measure only the electrical pressure, paid, between any 2 points. That's why ammeters are always connected in series, whereas the voltmeters are connected in parallel. Electromotive force, e.m.f. When electrons flow in a circuit, an electric current will result. The continuous flow of electrons in the circuit is maintained by a cell. Electromotive force of a cell is defined as the energy supplied by the cell to drive a unit charge round the whole circuit. The SI unit of e.m.f. is volt. Comparative study between e.m.f. and PD. Take the reading on voltmeter when the switch is open, i.e. when the circuit is open circuit. This reading gives the e.m.f. of the cell. Thus the potential difference between the terminals of a cell when no current flows through it, or when it is an open circuit, is known as the electromotive force, e.m.f. of the cell. Resistance. The conductor opposes the flow of electric current through it. The property of the conductor to oppose is called the flow of electric current resistance. The resistance of a conductor is its property that restricts the movement of free electrons through it. It is measured in ohm, in SI system, and is denoted by the symbol R. Factors affecting resistance. 1. The resistance of a conductor is directly proportional to its length. 2. The resistance of a conductor is inversely proportional to its cross-sectional area. 3. The resistance of a conductor depends on nature of material used. 4. A coiled wire has more resistance than a straight wire, length and thickness of each wire being same. Resistivity and conductivity. The resistance of a conductor is directly proportional to its length and inversely proportional to its cross-sectional area. The reciprocal of the resistivity, A, of a material, is called its conductivity, A. The SI unit of conductivity, A, is -1 meter 1. Ohm's law. The relation between current through a metallic conductor and potential difference across its ends was studied systematically by a German physicist, George Simon Ohm, in 1826 AD. This relation is now known as Ohm's law. Parallel combination of resistors loads. If the resistors are connected with their one side terminals at a common point and other side terminals at another point, and these common points are connected to the two terminals of the electric source, is called parallel combination of resistors loads. Series connection of electric loads resistors. If the resistors are connected end to end such that same current flow through all the resistors, the combination is called series combination of resistors loads. Effects of currents. We come to know that there are different sources and forms of energy. According to the law of conservation of energy, energy can be transformed from one form to the other. The bulb converts electric energy into heat and light energy. The heater converts electric energy to heat energy. An electric motor or fan uses electric energy to do mechanical work. Electric power. Electricity can do work in different ways, like running electric motor, electric heater, running refrigerator, charging batteries, etc. For example, an electric motor converts the electrical energy into kinetic energy, and a heater can change electrical energy heater can change electrical energy into heat energy.